Assalamualaikum and good evening everyone. Sorry for taking 10 minutes. Okay, 10 minutes late. How many already? Okay, Bismillahirrahmanirrahim. Alright, so are you able to hear my voice? Please respond in the chat box. Okay, boleh dengar suara cikgu? Okay, so now I can see there are 38 student. Semua SMK Batu Lintang student kah? So if BL student, so it means that we are repeating what we have learned in class, but cikgu summarize what we have discussed. Okay. Alright, so tonight we'll be focusing on paper 3, section B. Before this, cikgu plan to explain about transistor, right? But I need time to edit my slide. I want it to be perfect lah class. Okay, so that's why I take some time. Alright, so tonight cikgu tukar plan. Okay, since my slide is not ready yet. Okay, so we look at paper 3, section B. Okay, you can see my screen already, right? Okay, so this is tonight we look at resistance, factors affecting resistance. Okay, factors affecting resistance. Okay, look at this question. We have done this before. Alright, so diagram 4.1 shows bulb light up when connected to electrical circuit. So diagram 4.2 shows bulb become dimmer when the circuit exposed to the hot sun. Okay, like that. So look at the diagram. So using the same dry cell, okay, but the circuit are all the same. It's just that the first diagram there is no sun, and the second diagram you can see sun here. So it means that the two variable involved here will be the the sun will be temperature, right? Temperature, and another one is the The obvious here will be the brightness of the bulb. Okay, so okay, as usual for your paper 3 section B, so the first question will be asking you to write your inference, your hypothesis, then C1 will be the aim, C2 variable, and then C3 list of apparatus material, C4 arrangement of apparatus, and then 5 is the procedure, and then 6 is the way you tabulate your data, and then 7 will be analyze the data. So altogether the marks for this section will be 12 marks. Okay, so this part, okay, maybe we look at this first. Okay, so the right, so the aim here all will be 1 mark except for variable will be 2 marks. Okay, so the first mark will be for the manipulated variable and responding variable, correct. Okay, so manipulated and responding variable is 1 mark, and then your constant variable, okay, will be 1 mark. And then here 1 mark. Okay, procedure, there will be 3 marks for the procedure. Okay, so the first mark will be your first MV value, manipulated variable value, and then the second mark will be your responding, how you measure your responding variable, and then mark number 3 will be the repeat, means that you repeat your MV. Okay, repeat manipulated variable. Okay, now see procedure used in the experiment, which should include one method of controlling the manipulated variable. So means that the first mark manipulated variable, and then the repeat value. So that is how you control the MV, these two. And then method measuring the responding variable. So this is 1 mark. So means that the procedure will be 3 marks. Alright, so tabulate data, this must be shown by using table, and then analyze data, normally we use graph. Okay, so see, one mark, right? So aim, this is 1 mark, variable 2 marks here, and then list of apparatus material 1 mark, arrangement 1 mark, and then here will be 3 marks. Okay, and then tabulate data 1 mark, 1 mark. So altogether will be, see, 5 plus 5, 10 marks. Okay, so C will be 10 marks. Alright, so look at this. This is another diagram, okay, showing light bulb connected to conductor wire of identical length but different thickness. Then when the power supply is switched on, bulb lighted with different brightness. You can see, right? So here you can see the thickness of the wire are not the same. Okay, and then the brightness of the bulb also not the same. Then in terms of apparatus material, they give you the pattern of the question is the same lah, huh? Okay, just now this one is temperature and brightness. They give you, see, they give you constantan wire. And then here is brightness and diameter. They give you dry cell, constantan wire. And then the rest of the question, the pattern is the same. Okay, look at this one. So they give you, there are 2 electric kettle with different heating coil inside, which are used to boil same volume of water. So found that water in diagram 4.1 boil faster than the water in diagram 4.2. Okay, so here can see they are focusing on the thickness of the coil, right? Thickness of the coil wire, kan? Then they give you constantan wire, ammeter. Okay, then look at next question. So here will be brightness of the bulb and the length of the conductor. Next one, brightness of the bulb and still the length of the conductor. Okay, so here showing the brightness of the bulb are different, right? This is brighter. this is dimmer, and look at this point of the rheostat connected to P, and then here is connected to Q. So when you slide the rheostat, actually you change the length of the wire, so length of the length of the conductor. So it means that this is something to do with resistance and also length. Okay, next one. This is SPM 2019, last year question. Okay, but they see you don't see any battery, but they are using solar panel. Okay, connect to the bulb, and then this is shorter bulb, shorter wire. This is longer wire. So all of this question is actually factors affecting resistance. Okay, factors affecting resistance. But how to write? How to answer? So I can say that this factors affecting resistance is a famous question, selalu keluar. So you must know that the resistance, okay, of a conductor will be affected by the length of the conductor, will be affected by the diameter of the conductor, also affected by the temperature. Okay, another factors will be the type. Okay, but type normally so far I don't see any question relate to this. Okay, so we'll be focusing on this. Okay, because the length, diameter, and temperature are the physical quantity. Alright, so we're focusing on length, diameter, temperature. Now, basic will be like this. We do summary. So let's say we have our manipulated variable, responding variable, constant variable. So normally the responding variable, although you see the diagram shows you the brightness of the bulb, but actually the responding variable will be the resistance. Okay, resistance. So this is the responding variable. So if the bulb is brighter, okay, brighter, so means that current is brighter. So it means that current is bigger current. So current is bigger because the resistance is smaller. Alright? So remember this. When you write your hypothesis, you can relate to the diagram that given. So it means that you can use the word brightness. But when you write your inference, you can use brightness. But when you write your hypothesis, don't use brightness anymore. Okay, you need to focus on this resistance. Okay, so when you write your experiment, okay, so it should be the responding variable should be the resistance. Okay, now we look at the first one just now is temperature, right? So manipulated variable is temperature, responding variable is resistance, constant variable will be constant variable will be these two. Either you write length or diameter. If it is if the manipulated variable is temperature. If the manipulated variable is length, so resistance still the responding variable, but the constant variable will be temperature and diameter, like that. Okay, and if let's say the manipulated variable is the diameter, so responding still the same, the constant variable will be D, right? So it means that the constant will be L and T. Is it clear? Okay, so we normally write manipulated variable temperature, comma T, and then responding resistance, comma R. It's good to have the symbol. Okay, and then the constant variable will be length and diameter. Clear? Okay, if you are clear with this, then we look at the answer. Okay. So far, SPM question a few times already come out factors affecting resistance. It's either the diameter or the length of the conductor. I have not seen any past year question relating the temperature and the resistance. Okay, but you need to know about this lah. I think we look at the famous one first. All right. So diameter and the resistance. Okay. So these are the problem diagram. This is also the problem diagram, but the same marking scheme, which is the diameter and also the resistance. Alright, so we look at diameter and resistance first. Okay, so far, boleh faham? Can understand? If anything, you can write in the chat box. Cikgu baca. Boleh, alright. So, now, so what is the inference? What is the inference? You can type in. We discussed already, so now it's just refresh lah. Huh? Okay, so what is the inference for this experiment? For this problem diagram, sorry. What is the inference? What is the keyword that we need to use if you write an inference for physics? What is the keyword? Okay, yes, you can use the word affected by, you can use the word dependent on, okay? Dependent on, affected by. Okay, so I can see you all as typing. Vincent, resistance of wire depends on the diameter of wire. Theo, resistance of current. Resistance of current depends on diameter of wire. Jasmine, brightness of bulb depends on the diameter of wire. Brightness of bulb affected by the thickness of wire. Brightness of bulb depends on the thickness of wire. Alright, so in this case, when you write your inference, you can use the word brightness. Okay, boleh, huh? You can use the word brightness. So brightness for the inference. You can talk about brightness. You can talk about the resistance. Both will be accepted. Okay, so either brightness or resistance depends on the, you can write diameter, you can write thickness, you can write cross-sectional area. Diameter boleh, thickness boleh, cross-sectional area of the conductor also boleh. Okay, I just put A lah, cross-sectional area. Okay, so I read the chat box lah, tengok jawapan. Alright, Vincent, correct. Resistance of wire depends on diameter of wire, correct. Theo, resistance of current depends on diameter of wire. So we normally use resistance of the conductor. Okay, resistance of the conductor. And then Jasmine, brightness of bulb depends on the diameter of wire. Yes, correct. Chua is using the word affected by. Pun boleh, brightness of bulb affected by the thickness of wire. That is correct. Okay, Chang Hong sama. Yes, correct. Resistance of circuit depend on the diameter of wire. Okay, correct, Nathan. Brightness of bulb affected by the diameter of wire. Yes, semua betul. Comrade, both resistance and brightness. Yes, can. This is on only for the inference. Okay, only for the inference we accept the word brightness. Okay, so you can write brightness of the bulb depends on the diameter of the conductor. Only for inference. Okay, but hypothesis, don't use the word brightness anymore. Okay, because we don't have instrument in physics lab lah so far. So in your syllabus, we don't have instrument to measure the brightness of bulb. Okay, so the brightness of the bulb here actually represent the resistance of the conductor. Okay, so when you write your hypothesis, how do you write your hypothesis? Okay, now hypothesis. What is the keyword? So inference, we just write the not clear relationship between two variables. We know that this affect this, okay? But we don't know what is the clear relationship. For the hypothesis, you need to write clear direction, like it's either increase or decrease. Okay, Chloe. So when diameter increases, resistance decreases. Thicker wire, lower resistance. Yes, correct. Jasmine, greater diameter wire, greater resistance. Greater diameter wire, greater resistance. Okay, so cikgu baca first. Banyak message in the chat box. So I read first. Okay, now we discuss, right? So for the hypothesis, Chloe, diameter increases, resistance decreases. Okay, but add in conductor. Diameter of the when the diameter of the conductor increases, resistance decreases. Correct. Angeline, greater diameter wire, lower resistance. Yes, correct. Vincent, greater diameter wire, higher resistance. Okay, when you write your hypothesis, okay, we focus on Vincent's answer. Jawapan Vincent and jawapan Jasmine. Greater diameter of wire, greater resistance. Okay. In terms of writing hypothesis, this is a correct way to write hypothesis. You can write like that. The greater diameter of wire, the higher the resistance. The greater diameter of wire, the greater the resistance. Yes, you can write like that. But this is a false. When you do experiment, you will find that this hypothesis is false. Palsu lah. Okay, because the greater the diameter of wire, the smaller the resistance. Okay, so I don't suggest you to write like this. Okay, make it a habit to write correct, proven, true hypothesis. Okay, what is the reason? Cikgu tak dapatlah cerita online like this. Okay, so just follow, write the true hypothesis. Okay, but if you ask me, when you write like this, is it correct or not in terms of writing a hypothesis? Yes. In terms of knowledge, yes, this is the correct way of writing because their relationship is clear. The greater the diameter, the greater the resistance. But this is a false hypothesis lah. Will be proven false lah. Okay, so better to write. Cikgu tengok jawapan lain lah. Hubert, thicker diameter of wire, lower resistance. Yes, that is correct. Smaller diameter of wire, smaller diameter conductor, greater resistance. Ya, Tio betul. Chen, greater diameter, lower resistance of conductor. Yes, correct. Semua betul lah cikgu rasa kan. Okay. Cikgu terus turun bawah. See, comrade. The greater the cross-sectional area, the lower the resistance of wire. Yes. Okay, ingat lah. Yang penting, there are clear relationship between the two variable that you already decide just now. Alright, now, so the using apparatus given, okay, so normally they give one or two apparatus. So you look at the apparatus given, that can give you idea on what experiment you should write. So now, so need to write the aim, variable, list of apparatus material, arrangement of apparatus. So I have the answer here. Jab diameter. Okay. Alright, so this one already discussed. This one already discussed. Okay. So once you already write correct hypothesis, so the aim, just follow your hypothesis. Okay, here to study the relationship between diameter of conductor and the resistance. The susunan tak penting. You can write to study the relationship between resistance and the diameter of conductor pun betul. Okay, so you can use the word diameter, you can use the word thickness, thickness terima. Another one is cross-sectional area. Okay, so all of this will be accepted. And then variable, okay, see. So diameter of the conductor, so make it a habit to write symbol behind. Unit tak perlu, just write the symbol that you, because when you write your procedure, you will be using the same symbol. Okay, diameter of conductor D. Resistance also, make it a habit to write this. Good to have symbol behind. And then constant variable, length of the conductor, temperature, just what we discussed just now. Type, no need. Type of conductor, no need. Can we use small letter? Boleh. Okay, the symbol up to you. You can use capital D, you can use small d. Here you can write small d pun boleh. If you want to use A pun boleh. Okay, yang penting when you write your procedure, you use the same symbol. Constant variable, not because you seldom, okay, normally we don't focus on this. Tapi if you want to write the symbol pun boleh. No harm. But I will stress on the manipulated responding because later for your table you will be focusing on this also, these two. Your graph also you will repeat using the symbol. Okay, so these two good to have symbol. Okay, ada lagi soalan? Constant can write too. Boleh, can. But make sure both correct lah. Can we mention SWG of wire as manipulated variable? SWG wire. Here, for this case, the diameter of the wire changes. If you are talking about SWG, then it means that the diameter constant. It will be contradict. Okay, now, since the experiment is about diameter, okay, manipulated is diameter of the conductor. Katakan here, constant variable you tambah SWG of the wire. So this SWG, standard wire gauge, so this actually relate to the thickness of the wire. So this become contradict. Okay, so I don't advise you to use this SWG. Stick to the three variable that we have discussed. Ada 4 variable, maksudnya diameter, resistance, length, and temperature. So no need to use the word SWG. Okay. Reference book. Reference book write like this. No, if you write SWG here, it will be contradict. Can we write brightness of bulb in M? No. Okay, Jasmine, good question. Alright, so brightness, okay, can be only used in inference. Ingat lah. Inference, you can write brightness. Here, boleh tulis brightness. Brightness of the bulb depends on the diameter. Okay, this one boleh. But if you write for the hypothesis onward, you write brightness here. Okay, the moment I see this, cikgu terus cross. Okay, and then the moment I see brightness, okay, keluar here also cikgu akan cross. Okay, ingatlah Jasmine, and also the rest, don't write brightness. Okay, because we already decide just now, it is something to do with resistance. Okay, clear? Okay, good Jasmine that you ask. Okay, sometimes student they don't tak sedar this one. Okay, don't write about brightness. Okay, good question. Ya, ada lagi? Any more question? So from the hypothesis onward, okay, we stick to resistance because this experiment is actually factors affecting resistance. In this case, we are focusing on the diameter. Okay, so diameter and the resistance. So if you use diameter, so terus guna diameter. If you use cross-sectional area, terus guna cross-sectional area. Stick to the term that you decide in the hypothesis. Okay. Okay, next. Apparatus material. Apparatus material. So I suggest you all to write the instrument that is used to measure physical quantity in the first line. Okay. Tinggalkan satu baris lah. Okay, apparatus material. So make sure here you write your the instrument that you use. Okay. And then the second row, then you write other apparatus. Okay. So normally for this, you draw your diagram, apparatus arrangement. So what you draw here must be listed in the apparatus material. Okay. This one no problem. And then when you draw this circuit, all, okay, ammeter, battery, switch, rheostat, voltmeter. So this is the standard symbol. If you don't label also no problem. But the konstantan wire, this one wajib mesti label. This one wajib mesti di label. Okay, so this is the konstantan wire. And then connection, the ammeter must be in series. Voltmeter must be in parallel. Need to say no need. Okay. But when you draw the battery, careful with the terminal. Jangan lukis like this. If you draw like this, then sambung like that. This one, your diagram is not function. So it means that they will not give 1 mark here because the apparatus is only 1 mark. Okay, apparatus arrangement is only 1 mark. So the moment you draw the battery like this, okay, see what is the mistake here? Positive, negative, positive, negative, positive. So if you do like this, okay, here you draw tambah satu lagi here, small one maybe, like that. So if like this, salah. You know what is the mistake? Kan negative terminal, negative terminal. Alright. Ada soalan. Wanna ask, so special, what's so special about konstantan wire compared to, because the question, now, you can use other wire. Okay, you can use other wire, but normally we use konstantan wire. Okay, because yeah, it is an ohmic conductor. Can use other wire also. Copper also can be used, but copper is expensive. Okay, normally in physics that we use konstantan lah. Other wire can be used also. Okay, ada lagi soalan lain? Okay, next. So the procedure. So the first mark. Is it too big? So sekejap cikgu salah. Tunggu Okay, I thought it is too big. Can see Okay, so when you write the procedure, you write the procedure, so there are, because different experiment have different way we conduct. Okay, different way we conduct the experiment, but in terms of the 3 marks will be given for the first manipulated variable value, then the second mark will be for the how you measure the responding variable. And then the last one, the third mark will be for the repeat value. Okay, look at this. So which one is the first mark for the procedure? Because procedure is 3 marks. So can see here, experiment started using diameter of constantan wire, okay, 2 mm. So this is the first mark. So do you see how we write to get the first mark? Experiment started using, okay, this is the name of the manipulated variable just now, which is diameter. And then this is the symbol that you use in the variable just now. And then you write a value. Okay, so that is why when you write your variable, cikgu advise you to write, kan, manipulated variable, I advise you to write diameter, okay, diameter, comma, D. See that here, diameter, comma, D. Then you add in value. Remember that, that is the first mark. SWG unit is SWG is actually standard wire gauge that actually represent the thickness of the wire. We don't say that is the unit. Okay, so if you want to use, because SWG will be the bigger the number of SWG, the smaller the cross sectional area, kan? So it will be terbalik, you know. Okay, so since up there we use diameter, straight to the point, use diameter. Okay, terus guna diameter. Don't confuse yourself with the SWG. Cikgu tak kata salah lah, but I'm giving you a more simpler way to answer. Switch we draw open or close? Switch can be drawn open, can be drawn close. No problem. Okay. Step 2, 5 repeat. 2 to 5 repeated because answer only says step above is repeated. Okay, use diameter lah, Vincent. Lebih senang. Okay, don't confuse yourself. Okay, just use diameter or cross sectional areas. Okay, now, okay, so this is the first mark just now. Okay, experiment started using diameter of constantan wire D sama dengan 2 mm. Logic class, 2 mm. And then the switch is closed. This is important. Although this is no mark, okay, the switch is closed, but it is compulsory. Otherwise, your experiment, the responding variable cannot be measured. Kan, if you don't close the switch, maksudnya the switch is not on, then how come you get reading? Okay, mesti this one mesti priority. If it is electric experiment, make sure you write the switch is closed or the switch is on. Right, rheostat adjusted until the emitter reading is 0.5 ampere, and then potential difference V is measured using voltmeter and recorded. This one also keyword. Measured and recorded. For all the experiment, mesti ada ukur dan record. Okay, measure and recorded. The voltmeter, the potential difference V, measured using, this is the instrument, okay, and then recorded. Now, if let's say katakanlah you write until number 4 only and you forgot number 5, mark also will not be given because we don't know where is your resistance. This one mesti ditulis. Okay, so resistance R, this is your responding variable just now, is calculated using this formula. So when you write R equal V over I, okay, we will look at above here. What is V? What is I? If you already mentioned above, so this can be given mark number 2. Okay, V. What is V? So we will refer to this. Oh, already mentioned. What is I? We refer to up here, emitter reading. So this is the current. Cikgu terima lah. Like that. Okay, next one. Step above. So we understand step above here. Semua step di atas is repeated with the diameter D. Okay. you give 4 more reading. Okay, so this is 2 mm, so here 3 mm, 4 mm, 5 mm, 6 mm, so this is mark number 3. Active voice no problem. Okay, boleh, active boleh, passive pun tak ada problem. Okay, mark will be given. Rheostat must, yes, wait, rheostat must. If you don't write rheostat pun boleh, can also. Katakan you don't have rheostat here, also can. Okay, but it's better to have rheostat because we want to reduce the current. We want to make sure that the current is small. If the current is too big, then the temperature of the conductor will increase, so it means that your experiment will be not accurate. Okay, so that is why we have this kan rheostat adjusted so that the current is 0.5. So this step rheostat is adjusted so that current is 0.5. We fix the current. We fix the current so that the temperature is constant. Okay. Ada lagi soalan? Boleh faham? Any more question? Okay. Maybe some of the reference book or maybe some of the marking scheme, they are not using diameter. They might be using 1 wire, 2 wire, 3 wire. Like this. Okay, some might be using 1 wire. Then the experiment is repeated by using 2 wire, 3 wire, 4 wire. But you must mention they are connected in parallel. Okay, parallel. So means that when you use more wires, so the diameter increases lah. Like that. Okay, but if you ask me, I will suggest you to use the word diameter or cross-sectional area or thickness. Lebih selamat and easier for you to write also. Okay, next one. Okay, so that is how you tabulate your data. At least you have 2 columns. At least you have the manipulated variable and the responding variable. At least you have 2 columns. So potential difference, if you don't write here, also no problem. Okay, at least ada 2. Manipulated and the responding. And then the way you write, make it a habit to write like this lah. The name, the symbol, and the unit. Okay, here also name, symbol, unit. Can add 1 more column. Current is constant. So if current is constant, just write outside. No need to write inside the table. Sebab this is constant. Yet how many decimal place for diameter? So since this is only planning, you can write no decimal place pun boleh. Because this is only planning. As long as the number that you use, so they have a consistent change. It's like this, right? 2, 3, 4, 5, 6, 10, 20, 40 like that lah. Or 5, 10, 15, 20 like that. Need to write formula in column. No need to write formula. Because this one, resistant R stroke ohm. So the resistance just now, the formula already written in the procedure. So no need to write inside here. If I totally didn't mention about current in data, can. If you did not mention about that current in data, then how are you going to calculate your resistance? You need to mention about current in your procedure. then only you can calculate your resistance, because resistance kan sama dengan potential difference over current. Boleh, Vincent? Am I answering your question? I mean, I did not write in tabulation of data. Oh, okay. So means that you don't write current here. Is it? Is it what you mean? Okay, for the tabulation data, as long as you have two column, at least, okay, means that at least you have diameter and resistance. Okay, with you label like this, diameter D mm, and then resistance R stroke ohm, and then the value of the diameter, the manipulated variable written. That is already enough for you to get 1 mark. It means that without current, without potential difference, also can get already 1 mark. Faham? At least. But if you write like this, as what I give you here, this is the best way of writing tabulation your data lah. This is the best way lah. Because in the experiment kan, you already mentioned just now, you fix the current, you measure the potential difference, and you record. Then you calculate your resistance. So this is the best way to tabulate your data. Okay, but since this is only planning experiment, if you just write diameter and resistance, and you write down the value of diameter that you have mentioned above, then already can get mark. Okay. Alright, so last one is how you analyze your data. Okay, we'll be using graph like this. This is planning, so no need to draw inside here. Tak perlu lukis. Okay, yang penting is you have your graph. Please no need to use graph paper, just sketch it. Just draw the axis, okay, on your foolscap paper. And then it's good to have 0 here. Okay, good to start with 0. And then the horizontal axis, the manipulated variable. Vertical, responding. Just copy from here. Okay, exactly the same lah. Name, symbol, unit. There, name, symbol, unit. Name, symbol, unit. Is it clear? Boleh? Can? Can I have only symbol and unit without name? Uh, I advise you to write 3. Okay? Melainkan, let's say betul-betul tak cukup masa, then tak apalah, you write the symbol and unit. Okay, because the symbol and unit, symbol already standard, same as what you have given earlier here, right? Dah ada symbol, and then here also ada symbol, here also you use the symbol, the same symbol here. If katakan memang tak sempat masa, you just write D and unit, here also accept. Okay, but I will advise you to write 3 lah, all the time is 3, unless betul-betul tak cukup masa. Okay. Okay, alright. Macam now we discuss, so macam quite easy for you to know what is the variable, but this question actually confuse many students. Okay, look at this question again. Right, diagram 4.1 shows 2 electric kettle, because some students look at this as heat. Once they see, oh, electric kettle, oh, this is something to do with heat. And then this also, heating coil, they become, oh, this is temperature, or this is heat, Q. Some of the students think like that. But you need to further reading. Inside, used to boil same volume of water. Oh, volume. Then they say, MC theta, like that, so careful. Nampak macam heat, but then it is actually resistant and diameter. Okay, found that water boil faster. This one even menunjukkan something to do with boil, heating. So changing in temperature is until 100 degrees Celsius. Some students think like that. Okay, so need to look at the question carefully. Tengok betul-betul. Okay, because this is coil connect to the electric kan. Okay, connect to the electric, so it is something to do with resistance. So what makes the water in diagram 4.1 boil faster? It is due to higher more heat produced. Why more heat produced? Because the resistance is higher here. Okay, careful lah. Since we already discuss kan, so nampak macam senang. But if let's say you get the fresh paper, mungkin boleh confuse. Okay, so look at the question carefully. Take your time lah. Take your time to write the hypothesis especially. Okay, if macam inference salah sikit tak apa. If hypothesis salah, the whole thing will be affected. Okay, so we already look at this. Now look at the length. So this question. Okay, so diagram shows a shade being lighted up by lamp connected to battery using short connecting wire. That is 4.1. Okay, short, can see right? And then diagram 4.2, similar shade being lighted up by identical lamp connected to a battery using long connecting wire. Okay, so here you know brightness and the length. So inference can write the sama macam just now, but now is focusing on the length. The shorter the wire, the brightness of the bulb depends on the length of the wire. Ataupun the resistance of the wire depends on the length. Yes, betul. Comrade betul, Jasmine betul. Okay, inference can write about brightness. Hypothesis onward, no more brightness. Ingat lah Jasmine lah. Okay, so this one I think semua okay dah kan. Resistance depends on the length ataupun brightness depends on the length of the conductor. Hypothesis, the greater the length, the greater the resistance. The longer the you can use this also. Tapi cikgu prefer student to use in your inference you have length and resistance kan ataupun length and brightness. So here you use length also. Okay, so the greater the length, the greater the resistance. You can also use this, the longer the conductor, boleh. But I prefer student to use like this. Lebih nampak because this is memang MV, this is your RV. And then you use the word increase ataupun greater. Okay, so hypothesis no more brightness. Don't write brightness. M sama, use the variable just now, length dengan resistance. Quite easy now, right? Just tukar, just now diameter tukar dengan length. Okay, so again symbol unit. So these two betul, this is 1 mark. Salah satu salah, no mark Okay, this is considered as 1 mark. because already up here mesti betul bah, so this one will be only 1 mark lah. And then cross sectional area of the conductor. If you want to write symbol, boleh, can write D, you can write A, up to you. Another one is temperature. Yeah, temperature mesti constant. If you write only one variable, constant variable pun boleh. Okay, at least either one of this. Nak tulis dua-dua, okay, pun correct. There will be no, the marks for the constant variable will be only 1 mark lah. Apparatus material. Kejap. Apparatus material. For the diameter, the length just now. Kejap. Oh yeah, the length here. Diameter. Here. Apparatus material. So this is length and resistance. Ada kurang kah apparatus material? Length and... So here will be meter rule, right? Because length, meter rule. Meter rule. Okay. Meter RE, meter rule. Spelling cikgu. Okay, meter rule lah. Yang lain sama. Okay, this diagram also the same. Same as just now. The switch can be off, can be on. Tapi in the procedure, make sure you have that word. Switch on. Mesti ada. Switch close. You don't write switch is open. Switch open means switch off. Jangan confuse. Don't use the same istilah that you use buka lampu, tutup lampu. Okay, so it should write here, switch is closed ataupun switch is on. Don't write switch is open. Okay, switch open salah. So cara tulis sama. Kan? Experiment is started by using name, symbol, then the quantity that you use. What is the magnitude? This is the first mark. Then don't forget this, switch close mesti ada. Without this, your responding variable will be no mark. Okay, switch close. You have your ammeter reading, you have the symbol I, and then the value, then the potential difference V. Okay, using voltmeter, can see this word, measure, sentiasa ingat, measure and record. Measure using an instrument, name it, and then record. This one is the mark. Responding variable. Resistance, calculate using the formula. Same sentence as just now. Tukar only the length. This is mark 2. Okay, and then repeat. Make sure 4 reading. 4 plus 1 lah. What I mean is repeat 4 times so that the total manipulated variable that you use, there are 4 value. 5 value. So 40, 60, 80, 100. Campur atas means 5. So this is mark number 3. We can also use 20, 25, 30, 35, 40. You can write like that. And mesti ada unit. Some students love to do like this. Some students love to do 40, 60, 80, then 100. Then hujung sekali letak cm. Okay, I don't advise you to do like this. Okay, don't write 40, 60 and hujung sekali you write unit. No, don't write like that. Okay, tuliskan untuk setiapnya lah, because you know this is the third mark. Then tabulate data, masuk dalam. Copy what you have here. Jangan lain lah. If you use 20, 40, 60, make sure you write the same value. Jangan here jadi 20, 25, 30. Okay? Same thing as just now. And the graph. Okay, graph pun jangan terbalik. Okay, can we proceed? Okay, look at this diagram. Okay, so this one shows this is shorter, right? Shorter, brighter, longer, dimmer. So this is also resistant. Okay, resistant and the length of the conductor sama macam just now. This one also the same, length dengan resistant. Sometimes here they have macam incubator bah, yes, incubator. Sometimes they have egg inside here. Okay, boleh sama lah, sama. It will be resistant and the length also. Okay, this one is resistance and length. Okay, this one also resistance and length. The solar panel here represent the sama macam battery. Okay. Okay, last one. Last one. This one belum pernah keluar. This one is actually SBP question if I'm not mistaken, but I can't remember what year. Maybe 2018 maybe. Okay, so this will be temperature and resistance. Okay, temperature and resistance. So sama macam just now, they only give you constantan wire. If they give you other wire, use that wire. Katakan they give you copper wire, so use copper wire. Okay, jangan stick to the constantan wire. If they give you other wire, use what is given. Alright. Okay, so inference. Okay, this one is actually slide made by Setia, Chang and Tay, Chang Hong and Tay. So I'm using your slide. Okay, inference brightness of bulb depends on the temperature. Boleh terima ataupun the resistance of the conductor depends on the temperature. Hypothesis, the higher the temperature, the higher the resistance. Boleh. No more brightness. Okay, don't write about brightness here. Then aim to study relationship between resistance and temperature of conductor. Okay, sama kan? Now easy already, right? Manipulated temperature T, resistance R, constant diameter and the length of the wire. You can use wire, you can use conductor. Don't write about bulb. You don't write constant variable, the brightness, something to do about the bulb. No more bulb. Okay. And then this one is a bit different from the circuit just now. This circuit is actually, the basic circuit is the same as just now. Sama. Okay. But we manipulate temperature. If we manipulate temperature of the conductor, so the conductor must be heated. So you don't direct heat the conductor, okay, but we heat it by using water bath so that it will be constant temperature, so that the conductor have constant temperature. Okay, cikgu, okay, you see, apparatus material sama macam just now, tambah thermometer, and of course you need to have your tripod stand, your beaker, your Bunsen burner. Okay, cikgu want to zoom in this gambar. So just now, so the circuit that we have just now is like this kan. So we have dry cell, katakan you have 2, and then you have your switch, you have your ammeter, and you have your rheostat. Just now we have like this, sambung like that, right? And then you have your conductor and your voltmeter. So this is the constantan wire. This is the constantan wire. Now, terbalik. Sebenarnya, you can still draw the same diagram. Sama macam this. Okay, I draw. Cikgu lukis di bawah lah. Okay, cikgu padam this one. I just rub this. So, cikgu just terbalikkan. Voltmeter we put up. Because you cannot put water up here. Bah. Okay, so cikgu terbalikkan this part. So, you place your voltmeter up here. Then, this one sambung ke bawah. Okay, that is your wire. Okay, this is the constantan wire. And you put in a beaker. Water. Right. And then your thermometer. Of course, your tripod stand are your wire gauge. And also your tripod stand. And the heat. Okay, benda-benda like that. Okay, so at least kan boleh ingat, right? So this is actually the same circuit as just now. It's just that now the wire, we place it down here. Yeah, the wire must be coiled. Otherwise, because we need longer wires so that heat can be produced more. Kan? So must be coiled lah. We draw it coiled like that. Hypothesis. MV, RV. Jasmine, it depends on the sentence that you use. Katakan you write the greater. Okay, cikgu tengah jawab soalan Jasmine. Teacher, hypothesis MV, RV ke atau RV, MV? So, if you use the greater, katakan the greater something, the greater something. Katakan like this. Okay, so this one will be manipulated. This is responding variable. Atau if katakan, okay, in what situation do you use RV first? Yeah, in what sentence? Anybody can suggest? Coba cadangkan. What sentence? Because sometimes it depends on your sentence. If your sentence terbalik, okay, you need to write the responding first. If you use the greater, then guna MV first. Okay? Senang ingat like that lah, Jasmine. Inference, kalau inference, if you use the word dependent on, depends on, so this one will be responding variable first and then MV. But if you use the word affects, katakan, some student write like this. What affects what? So here will be MV first. Affects the responding variable, like that lah. But if you use the word affected by, okay, if you use affected by, will be responding first and then MV. So it depends on the sentence that you use lah. Good Theo. Yes, that is when you use the RV first. Correct. Okay, so katakan you use the resistance increases. Okay. Yeah, use S di depan. Okay. Yeah, correct. Look at Theo's answer. So the resistance of the conductor increases as the diameter of wire decreases. In that case, yes, you use the RV first, followed by MV. Boleh ke, Jasmine? But if you use the greater, guna MV first. Okay, Jasmine boleh? Okay, Alright, good. So if you have any question, just type in the chat box. Cikgu memang baca. Alright, now look at the procedure. This procedure ada lain sikit lah. So the apparatus setup shown in the diagram. So water is heated until temperature of conductor. Here be careful. So this is correct, okay. Temperature of water is heated. See, water is heated until temperature of conductor. Okay, temperature. Okay, good that you write this. Temperature of conductor. This can be given the first mark. Okay, but if you don't write, katakan you write, water is heated until temperature of water T equal to T. That will be a question mark. Because the manipulated variable is the temperature of conductor. Ataupun we just write temperature lah. Understood it is the temperature of the conductor. So if here you write temperature of water, that will be a cross. Okay. So water is heated until temperature of conductor. Ingat lah. But if katakan you just write water is heated until temperature T, 30, that one masih boleh terima. But once you write water is heated until temperature of water T, now your T is already referring to temperature of water, not temperature of the conductor. Do you understand me or not? Up here, okay, you already write manipulated variable is temperature of conductor. Okay, jelas. T is for the conductor. In the procedure, make sure you stick to that. Okay, water heated until temperature of conductor. Jangan tulis temperature of water. Clear? Then to get the first mark. Memang betul lah, need to write this. The switch is closed. Okay, rheostat adjusted until the emitter reading. This one is fixed. Okay, 0.1 ampere. Then voltmeter reading V measured and recorded. Resistance R calculate using the formula. Sama macam just now. Okay, so you see the keyword. Voltmeter reading V measured or tambah. Measured using voltmeter. Okay, and recorded. So resistance R calculate using the formula. So we can accept this formula because you already mentioned what is V, what is I. Then experiment repeated with temperature of wire. Okay. So here, jangan tulis temperature of water. If you write temperature of water, I don't give mark. Okay, should be temperature of the constantan wire. Okay. Okay, cikgu baca chat box. Teacher, can I write the constantan wire is deep in the water bath of temperature? Constantan wire is deep in the water bath of temperature. Kejap. You see, I'm thinking whether to give mark or not. Theta 30. So are you using T or theta for the symbol, Vincent? Symbol for temperature? In this case, we use T, but when you put theta there, are you using theta ke T? If let's say you're using theta, constantan wire deep in the water bath of temperature. That one I think will be referring to the temperature that you have written in that sentence will be temperature of the water, not the temperature of the constantan wire. Okay, it depends on how strict is the marking scheme lah. If they are strict, then they don't give mark. If they are not strict, mungkin boleh bagi markah. Okay, ada lagi soalan lain? Then your table sama macam just now. Okay, name symbol unit, name symbol unit. Okay, at least 2 column. At least you have temperature dengan resistance. Then your graph. Okay, temperature, resistance and temperature. Good to have 0 here. Okay, ada soalan? Any more question? Any more question? So we managed to discuss factors affecting resistance. Okay, so next time maybe we have one more. For paper 3, cikgu ada banyak lah because you all help me making the slide bah. So I can combine your slide, and can use it for this YouTube channel. Thank you so much. Alright, so now I can see there are 38 student here. Okay, very good. Semua Batu Lintang student ke? Ada pelajar sekolah lain ke? Okay, so hopefully you can understand, okay, how to answer for section B paper 3 for factors affecting resistance. Okay, so I think that's all for tonight, right? So wait sampai cikgu habis making my slide for transistor, then kita akan I will post lah. Okay, alright, so yeah, good night, thank you. Boleh, can. Ya, cikgu akan share in your group. Oh, reporting tunggu. Ada masa we discuss on that. Alright, good night. Okay. Alright, bye-bye. Sweet dream. Pressure. Bincang bicycle, pressure, boils. Oh, boils. Ya. Kita akan buat lah. Okay, we look at different problem diagram. Okay. Yes, good night. Yeah, stay safe. Use sanitizer, wash your hand. Farah ya kah? Which Farah is that? Farah Batu Lintang kah? Cikgu pun ada student nama Farah. Oh, yeah. SMK Batu Lintang is in Kuching. Yeah. Oh, happy to see you, Farah. Alright. Okay, so subscribe, tell your friend. Okay, so uh, we will have more live session like this. Okay, helping my student in SMK Batu Lintang at the same time helping other student. Okay, so hopefully. Oh, bulat lah ya, Tiara. It's okay. Seorang ni Farah. Oh, alright. Transistor, I need my time to make a better slide lah so that you all can understand better because transistor is a bit complicated but very interesting. Okay, so ada masa on the way, alright? So maybe hopefully by next week lah cikgu dapat buat. Okay? Alright, good night. Hanan from where? Alright. Okay, so cikgu off and stream. Oh, okay. Thank you, Hanan, for joining us. Alright, see you. Assalamualaikum warahmatullahi.